Welcome back to Josh Does Math. Today we're going to be combining a couple of derivative rules to find the derivative of this function that's on the screen right now. So just looking at this function, you can tell that there is an outer function and also an inner function. So that looks like we're going to base all of this off of the chain rule. So I'll start off with the chain rule. So let's say this is y. That means that dy dx is going to be equal to the derivative of the whole thing to the 3/4 with respect to just the inner function, which is x to the third, plus 8 all over x squared, times the derivative of the inner function with respect to x. So that's the chain rule right there. First derivative is easy. That's just going to be the power rule. Power out front. 1 smaller on the power, it becomes the negative 1/4 power. How about this over here? Well, this is a quotient, so I can use the quotient rule. Quotient rule says derivative of the top times bottom minus derivative of the bottom times top all over bottom squared, which is going to be x to the 4th. Okay, so now I'll do a little bit of rewriting in this next step. So this is equal to 3/4. I can apply the negative 1 power right here. So that's going to flip this. That's all it does, is it takes the reciprocal of what's on the inside. And it's still to the 1/4 power. Times, this is going to be 3x to the 4th minus 2x to the 4th minus 16x all over x to the 4th. However, 3x to the 4th minus 2x to the 4th, well, that's just 1x to the 4th. So now I can rewrite this one final time, and I'll get 3/4 times, I'll write this as the 4th root, the 4th root of x squared over x to the 3rd plus 8 times, what if I factor an x out of the top and bottom and cancel them? Well, I can do that. X to the 3rd minus 16 all over x to the 3rd. So this is the final function right here that is the derivative of the original. So we just use the chain rule and use a couple other derivative rules, and that's all there was to it. Thanks for watching.